The electrical code generally prohibits the installation of individual number 12 THHN wires in an open ladder cable tray for 480-volt three-phase motor circuits. This prohibition stems from several factors related to safety, ampacity, and proper installation methods. Cable trays are designed to support and route groups of conductors, cables, and raceways. Using individual wires in a cable tray, especially for higher voltage applications like 480 volts, can present several challenges. Firstly, physical protection is a major concern. Individual wires in an open cable tray are more susceptible to physical damage from impact, abrasion, or environmental factors compared to conductors installed within a cable or raceway. The cable tray itself provides a degree of protection, but it is not designed to shield individual wires from all potential hazards. Secondly, proper support and securement are critical for maintaining the integrity of the wiring system. Individual wires in a cable tray may not be adequately supported, leading to sagging, strain on connections, and potential for insulation damage. The code requires that conductors be securely fastened to the cable tray at appropriate intervals to prevent these issues. Thirdly, ampacity dirting is a significant consideration. When multiple current-carrying conductors are installed in close proximity, as is often the case in cable trays, the heat generated by the conductors can raise the ambient temperature within the tray. This increased temperature reduces the ampacity, or current-carrying capacity, of the conductors. The code provides ampacity correction factors to account for these effects, and it may be necessary to use larger conductors or reduce the load in the circuit to comply with the code requirements. Fourthly, voltage drop can be exacerbated by using individual wires in a cable tray. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the impedance of the conductors. The code establishes limits for voltage drop to ensure that equipment operates properly and to prevent overheating of conductors. Using individual wires, especially over long distances, can increase voltage drop and potentially violate code requirements. Fifthly, proper identification and labeling are essential for maintaining a safe and organized wiring system. Individual wires in a cable tray must be clearly identified to indicate their purpose, voltage, and circuit designation. This identification helps prevent accidental contact with energized conductors and facilitates troubleshooting and maintenance. Sixthly, the NEC addresses cable tray installations in Article 392. This article provides specific requirements for the types of cables and conductors that are permitted in cable trays, as well as the installation methods and support requirements. Generally, the code favors the use of jacketed cables or conductors installed in raceways within cable trays, as these methods provide better protection and support for the conductors. Seventhly, for motor circuits specifically, the code emphasizes the need for adequate overcurrent protection and motor control. The motor circuit conductors must be sized to carry the motor's full load current, and they must be protected by an overcurrent device, such as a circuit breaker or fuse, that is sized appropriately for the motor's characteristics. Eighthly, grounding and bonding are critical safety measures in any electrical installation. The cable tray itself must be properly grounded to provide a low impedance path for fault currents, and all metallic enclosures and equipment must be bonded together to minimize the risk of electric shock. Ninthly, when considering alternatives to individual THHN wires in a cable tray, several options may be more code compliant and provide better performance. These options include using Type MC cable, which is a metal-clad cable that provides excellent physical protection and is suitable for cable tray installations. Tenthly, another option is to install the THHN wires in a conduit or other approved raceway and then run the raceway in the cable tray. This method provides additional protection for the conductors and simplifies installation. 11thly, it is important to consult the specific requirements of the local electrical code and to obtain approval from the authority having jurisdiction (OJ) before installing any wiring system. The AHJ has the final say on whether an installation meets the code requirements and is safe for use. 12thly, when working with electrical systems, it is always essential to prioritize safety. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves, and always to energize circuits before working on them. 13thly, it is also important to have a thorough understanding of the electrical code and to follow all applicable safety procedures. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. 14thly, in some limited cases, the code may permit the use of individual THHN wires in a cable tray, but only under very specific conditions. For example, if the wires are used for control circuits and are installed in a cable tray that is specifically designed for this purpose, the installation may be acceptable. However, it is essential to consult the code in the THHN to determine whether this type of installation is permitted in a particular situation. 15thly, the requirement for using cable trays include NEC section 392.3, which states use is permitted. Cable trays shall be permitted for exposed wiring and cables in accordance with 300.11. Only the cable and wiring methods as covered in this section shall be permitted to be installed in cable trays. 16thly, NEC section 392.3b states use is not permitted. Cable tray systems shall not be used in hoistways or were subject to severe physical damage. Cable tray systems shall not be used in environmental airspaces except as permitted in 300.22. 17thly, NEC section 392.10 contains cable and conductor installation methods. Cables and conductor shall be installed in accordance with 392.10 through E as applicable. 18thly, single conductors number 1/0 AWG and larger shall be permitted to be installed in cable trays. Where installed in accordance with Article 392, single conductors shall comply with 310.14 ATWO, A3ND. 19thly, single conductors shall be securely bound in circuit groups. 20thly, where number 1/0 AWG and larger single conductors are installed in a single layer in uncovered trays, the maximum size of the tray shall be 101.6 or 4 inches. 21stly, NEC section 392.20 contains cable and conductor securement, which states in other than ladder type cable trays, where single conductor cables are installed, all cables containing conductors number 1/0 AWG or larger shall be secured to the bottom of the cable tray by cable ties or other approved means. The cable ties or other approved means shall be distributed such that there is securement alternating approximately every 760 or 30 inches. Single conductors shall be installed in a manner that does not result in damage to the cable. 22ndly, if individual number 12 THHN wires are not permitted in an open ladder cable tray for 480 volt three-phase motor circuits, the alternative wiring methods allowed in cable trays include armored cable, such as Type MC cable. This provides a metallic sheath for physical protection. 23rdly, metal-clad cable, Type MC, in accordance with Article 330. MC cable is a factory-assembled cable containing one or more insulated conductors enclosed in a metallic sheath of interlocking metal tape or smooth or corrugated metallic tube. It is suitable for both exposed and concealed work and can be used in cable trays as per NEC 392. 24thly, another allowed wiring method includes metal raceways with individual conductors. Install THHN wires inside a rigid metal conduit, intermediate metal conduit or electrical metallic tubing, and then support the conduit or tubing in the cable tray. Rigid metal conduit, intermediate metal conduit and electrical metallic tubing, each in accordance with Article 344, 342 and 358 respectively. These raceways provide excellent physical protection for the conductors and are permitted in cable trays. 25thly, cable trays are used to support cables and raceways, not individual uncabled conductors, with limited exception for large conductors. Smaller single conductor wires like number 12 THHN typically require additional support and protection. 26thly, voltage considerations include 480 volt systems. These require robust insulation and protection methods because they carry higher voltage, which is more dangerous. Open cable trays with individual wires may not provide adequate protection against insulation breakdown or accidental contact. 27thly, open ladder cable trays are suitable for supporting cable assemblies and raceways, but they do not offer the enclosed protection required for individual THHN conductors, especially at 480 volts. 28thly, it is essential to adhere to the NEC and local codes to ensure electrical installations are safe, compliant, and reliable. 29thly, cable trays are essential components in electrical systems, providing organized and accessible pathways for cables and conductors. Understanding their proper application and the limitations related to wiring methods is crucial for safe and effective electrical installations. 30thly, the NEC specifies the types of cables and wiring methods that are permitted in cable trays to ensure that the installation meets safety standards and performance requirements.